students, this is Dr. John, your physics and math professor, and today we're doing another fun video on transformations. Previously, we've done transformations on various different shapes and equations, quadratic equations, and sine and cosine, things like that. Today, we're going to be doing it on this trapezoid. And you can apply the principles we're going to use today to any various shapes, to any shapes that might be an odd shape like this. So when you have something like this, what you're going to do, you're going to transform it. Here I've redrawn this just slightly bigger so it's a little bit easier to see. I'm going to do these first three transformations right on here, and then I'm going to do the fourth one on here because I'm going to need a little bit more space to do calculations over here. The first three I'm just going to do sort of in our head because you can do that often with some of these. So I'm going to try to color code these. I'll make the first one brown. So here we have a function. This little box here, this trapezoid is a function. Actually, it's not a function. We're just using the f of x notation. This here is f of x, this original thing here. That's f of x. But it's not actually a function, because remember, a function, this is the independent variable, this is the dependent variable. We need to have, in a function, the dependent variable, that's the y, has to be completely dependent upon the x. Give me an x, I'll give you a specific y. Well, if I give you any of these x's, you're going to have, you could get this y, or you could get the y's over here. So this is not a function. It's a relation between the x and the y points. You can also do the vertical line test. If you draw a vertical line like this, then that vertical line will intersect this thing, this trapezoid, in more than one spot, and that makes it not a function. So that's a test that you can do. But I'm just going to use the word function because I'm used to using it, and we've written here f. So the f of x is this original thing here, this original trapezoid. We're going to be doing these transformations. We're going to be doing an f of x minus 2. Now notice here the x minus 2 is inside the function notation. That is, the function is being applied to everything inside the brackets. The x minus 2 will be then applied to the x-axis. Anything inside the function, anything inside the brackets is applied to the x values. Anything outside, like this thing is outside, this 1 here is outside, the blue one, those are going to be applied to the y value. And also another trick is anything inside the function here, which is applied to the x, we're going to do the opposite of. So if it's a minus like this would be a translation. It's going to be a shift to the right, not the left. If it is like over here, which is more complicated, if it's a stretch factor, and it's a stretch factor of say 2, if it looks like it's at 2 times here, it's actually going to be a stretch factor of 1/2. It's going to be like the opposite of anytime it's inside. If it's outside, it's going to be exactly, this is a stretch factor of 2, and this is a translation of 1 in the y direction. Those things might help you to remember that. Also, if you think of this inside here, why is this a move to the right? Because you want to have the same y value. And how to get the same y value? Where you're going to have to make x2 bigger. You're going to have to increase the value of x here. So for example, if you want this to be 0, you would plug in 0 there. Now you have to plug in 2. So you have to shift the whole thing to the right by 2. So we're going to start off with this one over here. Remember, this is a shift to the right. We're just going to take the x values. The x value is this one over here, which is 1. We're going to shift it over to be 3, right over there. And then this value over here is going to be shifted to 4. This one shifted to 3. And then this one over here shifted over there to 4. So here's the shape that we're going to have, the new shape. This is this one over here. So it's just a simple shift to the right by 2. Now this one over here is f of x. F of x is like the y values. The y values are over here 1 and 2, minus 1 and minus 1. And what this does is it says take whatever y value you're getting and add 1 to it. So everything's going to be moved up by 1. I'm going to use this blue one. I'm going to draw it right on top of this one, but I'm going to just shift it over a tiny bit so you can see it. If we're taking all the y values, the x values stay the same. The y values move up by 1, so that's going to be that point there. This point will become this point. This will become this. This one will become this. And this one is going to go up to here. I'm just shifting it a tiny bit so that you can see it, because otherwise I'm drawing one right on top of the other. This really is right on top of the black one there, but I shifted it over a tiny bit just so you could distinguish it. Notice the shape here stays exactly the same, and here it stays exactly the same, because both of these are translations. If you remember from our other videos where I introduced these, if you haven't looked at those yet, do those now. Go back and check out those previous videos. Translations are like you get on a bus and you're translated. You're moved from one place to another, or you translate your language from one to another. You keep the shape exactly the same. The shape doesn't change. You just move it around, up and down, left and right. Here we moved it up, here we moved it to the right. So that's these first two. Now this is here is a stretch. With a stretch, or if you're shrinking it, if you're squeezing it, you're going to get some slight change in the shape. Here we're going to multiply every y value by 2. So we'll take this original function here and multiply it by 2. This one over here, it's minus 1 multiplied by 2 will give me minus 2. Let me shift it a tiny bit that way so you can see it. This one here, being doubled there. And this one over here is 1. It's getting moved to 2. Now this one's a little odd. It's 2. It's going to be moved to 4. So it's going to be moved way up there. So now notice if I connect these, I'll maybe make this. I shifted this again a tiny bit to the left of the black one and of the blue, just so you can see it. Really, they should be right on top of each other. Now notice here, the negative ones are stretched in the same direction because it's just multiplied by 2. And it sort of keeps the same shape. But this one over here is stretched to be double. This one over here is double as well, but because it starts off bigger, it actually gets way bigger. So you're actually stretching the whole thing like this as well. You're sort of distorting the trapezoid. That's what stretches will do. They will take your general shape here, or this black one over here, is going to stay, but it's slightly distorted. So be aware of that when you're doing stretching. So here I've done these first 3 sort of color-coded over here so you can see them. I've done them without using mathematics. And sometimes you can do that with this. This third one, though, is a little bit complicated. It's got some convoluted things inside there. So I'm going to take this, rewrite it up here, erase some things over here so I have room to work. Give me 2 seconds. So here I've done what I said. I've erased everything over here, rewritten this more complex function over here. As you can see, here's a stretch factor. Remember what I said? If it's outside the brackets of the function, it's applied to the y. So this is a straight up stretch of 2 in the y. This is a translation down in the y, but these things inside here both apply to the x. However, notice that's sort of tied together. We always want things like this. X minus 2 times 3, where this is a stretch factor. This is all inside the function here like this. This is a stretch factor. This is a translation to the right in this case. So remember, we're doing the opposite. This would be a stretch factor of 1/3 or a squeeze of 1/3. So we have this here, and notice this is sort of tied together here. We don't like a number straight in front of the x. We want it bracketed like this. So we want to deconvolute this here. So let's do this. So here I've rewritten this function over here, and I've still put a 2 in front of there. I've just changed these brackets here to be big square brackets because I want to take out the minus 1/2 here from the x, just like that. And then I'm going to still have to include this. So what if I make that plus 1 and put a bracket around like that? So what's this going to be? This is going to be minus 1/2, which is minus, this is minus 1/2. Whoops, that needs to be change that sign. So make that a minus, that's minus times minus plus 1/2. You may have to do these a couple of times, guessing them, or you can actually divide it. Take this and divide by this, and you'll get this number here as well. That's a more complicated way to do it. Often you can just do these by looking at them. So now we've got this in the form where there's a stretch factor here, and here there is a translation factor, and then we still have the minus 1 at the end here. Now what we do is we take these and we say, what do we do to the x values and the y values to create our new values? I've written all the old values from here, 1, 1, 2, 2. I've written these. What you do is if you're trying to take this and do a transformation on some shape, take the extremes. So take a couple of points. If you have like a smooth curve, take a couple of nice points. If you have something with extremes like this, take all the extreme points, write them down. This is the old x and the y. This is the old x and the y, and now we want to get the new x and the y. What are we going to have to do with it? We'll start off with the x values. You can actually do them separately. Notice the x values, we have a stretch. We do first SRT, or you can remember it by sort. This is how you sort them. S, stretch, reflect, translate. We do them in that order, but you can often do these two together. The stretch, you can think of the reflection as being a negative stretch. So here you would think this is a stretch of 2, because we're flipping it over, and then a reflection times minus 1. Or you can just say this is, we're taking whatever x value we have here, and we're multiplying it by minus 2. Because that's like a stretch of 2, and then a flip over the axis, over this axis over here, over the y-axis, a reflection by minus 2. And then we're adding 1. Because remember, we're doing the opposite. When it's inside, we do the opposite. And then the y value here, whatever y value we start with, we multiply by 2, like that. And then we're going to subtract 1. This is a minus 1. When it's outside the function, applied to the y, we do exactly what it is. When it's inside, we do the flip or the opposite. Of course, the negative still stays a negative. So you can do the stretching and the reflection all together like this. Now let's do these calculations. It's fairly straightforward. 1 times 2 is minus 2, plus 1 is minus 1. And then this over here is minus 4 plus 1 is minus 3. This again is minus 2, so minus 1. And this is the same as that, minus 4, minus 3. I would just double check them always like that, so that if you're doing them twice, that way if you make a mistake, you're not just copying. Over here, 2 times the y is 2, minus 1 is 1. This one here is 4, so that's 3. This one here is minus 2, so minus 3. And this one here, the y value, minus 2, minus 3. So there we have the values. I'm going to take these. Give me a second. I'm going to plop those on over there, and then I'll come back and I'll show you what I did. All right, I've taken these points over here, minus 1, 1, put them over here, minus 3, 3, minus 3, 3, minus 1, minus 3, and minus 3, minus 3. I put them over there. Now let's draw this shape. So notice here that this new shape, the mauve one, has a lot of resemblance to this one over here. For one, it's stretched in this direction. The distance between here and here is 1, but between here and here is 2, so that makes perfect sense. It's also reflected over the y-axis, as it should be from this right here. So that makes sense. It's shifted up and down a little bit. So this new shape here seems to be right. I would go back, rewind this, see if I can do these 4 exercises again, see if you can do them by yourself. And I hope this helps. If it does, like and subscribe, and I will see you in the next video. Bye-bye.